Hello again. If you have reached this point, then you have a lot of patience and you really want to learn more about Oracle machine learning on Python. So this time we're going to create a task for classification using a naive Bayes algorithm to create our machine learning model. And for the first time, we're going to try to improve the performance of the model, the score of the model in this case. Not the performance, not the make it faster, run faster, but to have a better accuracy. I'm going to create the data set, the data frame from my customers table in the database, and I'm going to drop the numerical values in the LTV, the entire LTV column, which is not used for classification. This is for regression. So as I said, I'm going to run classification, so I don't need this column. And then I'm going to split the data into testing, training, and testing using the default ratios. Here are the number of records we have in each one of the splits. And then I'm going to create my training and testing data frames. Training is train X with the attributes and train Y with just the labels of the LTV bin classification labels. And for testing, I'm going to take the second part of the split, the 4,645 rows into the test LTV data frame. And I'm going to provide my weights attribute, my setting in my settings for the naive Bayes model. So here are my my settings, and now I'm going to create my naive Bayes machine learning model using those settings. Basically, I'm using the default settings, and I changed just one single value in those settings. And now I'm going to fit the model I created with the training data. And I'm going to also specify that individual records are differentiated by the customer ID. This is the column which identifies individual customers in my data set. And I'm going to print this is a very simple learning model. It creates really, really fast. I'm going to print the details of it just to see how it worked. So this is naive Bayes algorithm classification. The target is the LTV bin classification labels, low, medium, high, and very high. And then I have the settings I can change to make it be more accurate and to make it more performant. It is not partitioned, and here are the probabilities. So naive Bayes algorithm is based on priors on the probability of certain attributes to occur in a certain class, and it calculates those conditions in order to identify and to predict those classes by the attributes in my data set. And I'm going to list the 10 most important conditions, conditionals in my data model for customers to be classified as very high customers and the probability of occurrence. This is how the naive Bayes algorithm works. So you can see here, car ownership is the most important attribute for a customer to be defined as very high customer, and the probability is 100%. So basically, in order for a customer to be a very high class customer, this customer must have a car. This is the most important attribute, let's say 100% probably. And then the credit balance. It also is very probable to have a high credit balance. So we have here also the values. So the marital status has to be in divorced or married. And this is 78% probable for customers to be in the high, in the very high range of customers. And here we also have the number of customers basically complying with this condition, with the conditions you see here. So we have the attribute, the values, and then we have the probability and also the number of customers. Let's use the model to make some predictions. Let's use the naive-Bayes models to see how it can predict the classes, the lifetime value classes on the testing data, on test LTV. And I'm going to print the customer ID, last name, first name, and I'm going to also print the pre-label just to compare the results, the predicted result, with the value which is actually the correct value in my LTV bin column. We can see here for the first one, the prediction is correct. The second one is correct. The third one is not correct. Fourth correct. Fifth correct. Sixth correct. So many values have the correct predicted class in which they belong using this machine learning model. But let's see the score actually. How accurate is this model? This model is 50% accurate, so it means that it's not accurate at all, to be honest. This is a really bad machine learning model, and we need to improve it. Definitely, we need to improve it. And there are ways to improve the naive-Bayes model by specifying pre-calculated priors. Priors based on the label, the pre-labels we already have. So I'm going to check the pre-labels with the number of customers and the probability they occur in our data set. And now I'm going to take this numbers, this count values, and I'm going to calculate the priors of my labels on the entire data set, dividing them with the total number of customers, 15,342 customers in our entire data set. So in this case, we can see that 48% of the customers are high, in the high class. 9% of the customers are in the low class. 33% of the customers are in the medium class, and 10% are in the very high class. So these are the pre-calculated priors we can specify in the model in order to make it calculate or predict the classes better than it did in the previous run when we didn't specify the priors. This is a way of biasing the classification model. We can also use costs like we have seen in the previous executions, or class weights. But prior probabilities is another way of biasing the classification models and make them return certain predictions in order to improve the model accuracy. So I'm going to create a table for this prior probabilities, specifying the percentage of values we have in each one of the customer classes in low, medium, high, and very high, using the values I just retrieved from the data set. I'm going to create this table, and this is going to be created in the database. It's going to be named naive-Bayes prior probability LTV. And now I'm going to refit the model using also the weight balanced off setting with the priors data frame I just created, and we also saved in a table in my database, the priors data set, which is created here in this block. So I'm going to try to convince the model that not the customers are not the classes in which the customers are not evenly distributed. So we are trying to make it enhance the accuracy of the results we retrieve from this naive-based model. So again, this is the new model with the refitted settings and training data, using the new settings and the training data, the same training data, but using the priors in this case. So let me see how much we have improved the score. First, we're going to run the model again on the test data to see more or less what it is predicting. Again, we have good results, good predictions, and bad predictions. So we cannot see exactly from this sample here how much the model is scoring, but we're going to run the score. And this time we have improved the scoring from 50%, sorry, from 50% to 58%. So we have increased the accuracy with 8% on our classification machine learning model. We can change more settings, and we can try to improve the model even more. So this is usually how we do it. We create a machine learning model. We use some settings. We tune it, and if we want to follow this this way of manually improving the accuracy of a model, we can do it, and we can test it multiple times and see how it performs. Or we can use the AutoML functions as we have seen in the AutoML exercises. AutoML is a lot more easier to use than running it manually like this and improving the model scoring manually. So I have identified some settings here, and I changed those settings to further improve my score. And then let's see how much I improved the score of my model. So the last tuning attempt I do manually is to change the settings and retrain my model again with the priors and the new settings. And I improved my model to 64% accuracy. From 50%, I managed to reach 58, and now I reached 64. It is a pretty bad machine learning model, I say, but it is a way of doing it manually if you want. So I wish you good luck. Thank you very much.